All right, students, this is going to be a series of videos that for me to answer this particular packet of problems, which is our final exam review questions. This is also a packet that I have shared with you already, and so you can follow along with this video. Again, it's going to be broken down into a series of videos. In fact, for example, the first video that consists of for question 1, 2, and 3, we have already done that in our in-class lecture. So you will have a separate video recording of that for the first 3 problems. So I'm going to skip number 1, number 2, as you can see over here, and number 3, which is this linear equation problem, linear system problem. And we're gonna be going over this problem. Right now here is a review of system equation. It shouldn't be too difficult for you. So let's go for it. When you have equation like this is a very straightforward. You even learned this in Algebra 1, so I'm not going to belabor too much. I'm going to go quickly. I said this one as equation 1, equation 2. I labeled them easily so I can think of it more systematically. I'll take and right now I'm going to use a method of elimination. I want to be able to get rid of x first because x has 3 coefficient and 4 coefficient. Much easier to find the common factors. Whereas for y you got 7 and -9. So I chose to find common factors for the x. So I'll take the first equation and I'll multiply by 4. This means 4 times 3x plus 4 times 7y equal to 4 times -29. So that is going to give me 12x plus 28y is equal to -116. So I'll call that equation number 3. Okay, and then I'll take the second equation and I'll multiply by 3. So I will end up with 12x minus 27y, right? -9 times 3, and equals to 53 times 3. You end up with 159. So that's fourth equation. So I take the 3. So what I will do is I will take the third equation and subtract the fourth equation. I go ahead and subtract them. 12x minus 12x is equal to 0. 28y minus -27y, you end up with 55y, and -116 minus 159, you end up with -275. So you divide both sides by 55, right? Divide both sides by 55. Then you end up with y equal to -5. Then you take this number, right? Y equal to -5. You put it back into 4x. Take whichever equation you want. You can take it back into equation 1 or equation 2. You should be able. I'm going to fast track this one. X is equal to 2. So your answer is 2 and -5. Now I have written up in terms of coordinate because you have a line for the first equation. And you have another line, second equation. 2 equations crossing each other gives you a point. So 2 and -5 is precisely the x value and y value as a coordinate. Alright, let's go on to the next question. Next problem is also a system equation, but both equations, as you can see, this equation is a quadratic. In fact, it's a circle, and then the second one is also an ellipse. We may not have gone over the conic sections, but the principle of solving this equation, the system equation, is exactly the same, which is system elimination. So in this case, I want to eliminate x. It's much easier because you only got x squared term for just one x squared. One term would consist of x for equation 1, and one term consists of x equation 2, whereas equation number 1 you got 2 terms containing y. So it's easier to just get rid of x. Okay. So if you have equation 1 set of, I label equation 1, equation 2. So in this case, I want to take equation 2 minus equation 1. You can do it in reverse, just make sure, doesn't really matter. 1 minus 2 or 2 minus 1 makes no difference. You just want to be attentive to the, the positive and the negative in front of each coefficient. So if I take the 2 minus 1, so I'm gonna rewrite the second one, right? So I'm gonna just line them up nicely. So I get x squared plus 5y squared, and I'm gonna keep it a little gap here and set it equal to 49. The reason why is because, let me see, this is equation number 2. The reason why is because the gap that I left here is because I want to line up. I noticed that equation 1 has 3 terms. So equation 1, I put it down here, x squared plus y squared minus 4y is equal to 21. I set that equal to equation 1 right here. So you see each term is lined up nicely. There's a gap here, so the way I will keep track of it is I'll just plus 0, make that into the lining each term. All these terms up nicely will ensure that I don't make silly mistakes along the way. So now I can go ahead and subtract them, right? Because I intended to subtract them. X squared minus x squared is gone, so that term is out. 5y squared minus y squared, you end up with 4y squared. 0 minus negative 4y turns out to be positive 4y. Okay, this is very important point. Gotta keep track of the sign. If it's a minus of a negative 4y, make sure it becomes a positive 4y. Okay, a lot of students make mistakes over here. I've seen this over and over in many years of teaching algebra. Students often forget the negative, and then you end up with the wrong answer. Okay, now then you have 49 minus 21. And it gives you 28. Okay, so this is our new equation. Okay, I have eliminated the x. Now notice this is almost look like a familiar quadratic equation in terms of y. So what I would do then is just actually write it in the formula I am familiar with, which is 4y squared plus 4y minus 28, and set it equal to 0. Now if I do that, then you notice immediately this is a quadratic equation form. Now I also notice that these terms are all in a factor of 4, so I can factor out 4 y squared plus y minus 7 is equal to 0. Now I can divide both sides by 4. 0 divided by 4 is 0. So I end up with y squared plus y minus 7 is equal to 0. See, then this is a quadratic form. So you can think of it as, right, a is equal to 1, b is equal to 1, c is equal to negative 7. And the quadratic formula in this case, right, is y is equal to negative b plus minus, well, the reason why I say y is because this is solving a equation in terms of y, not x's. So that's the reason why I say y. Y is equal to negative b plus minus square root of b squared minus 4ac over 2a. So in this case, you will put in negative 1 plus minus square root of 1 squared minus 4 a c over 2a. And this is at this point for this level, what I would ask you is simply just use your calculator to come up with a new numerical value. So if you do that, you end up with negative 1 plus minus square root of 29 over 2. Then you end up with, using a calculator, you end up with two answers, 2.19 and negative 3.19. So you have y is equal to these two numbers, so then you will take each number and you plug it into one of the equations, right? One of the equations, x squared plus 5y squared equal to 49, and solve for x. And you do the same, right? Put it into the equation and solve for x. So I'm not going to belabor this point too much. You have the calculator, you can put it back in there, do the algebra necessary, and come up with the x value. Then you will have the corresponding coordinates for x and y. Okay? All right, next. The next problem is an exponential problem. This is something that we have just gone over pretty recently in the most recent test. So let's go with this. The number of bacteria in the bottom milk increases exponentially. So when I read this, I know that this is an exponential function problem. Even if there's no heading here, when I read it, that's what I'm going to see. Assume that there are 56 million bacteria at time equals 0, 204 million at time equal to 2 days. So here is the setup right here. Any problem like this will give you a setup where it gives you a hint, a clue of what kind of function or relationship that you're going to be dealing with. So in this case, this is a exponential function. Y is equal to a times b to the x. Right? This is our general form for exponential function. But then it also gives you two data points, right? And in this case, time is independent, number of bacteria is dependent. So we can say time, t, and n, number of bacteria. So in this case, I can just put it right here, 0 and 56 million, right? This is in terms of million. And t equal to 2 days. We end up with 204 million. So I can rewrite this equation based on the variable that I use. So I can say n is equal to a times b to the t power. So now I can use the first data point, use 0 and 56, right? 0 is time, 56 is n, so 56 is equal to a times b to the 0 power. Now anything to the 0 power is equal to 1, so that means a is equal to 56. Now I found a, I need to figure out what b is, so I'll use the second data point, which is 2 and 204. So 204 is equal to a which is found out, right, which is 56, times b squared, because t is 2. So in this case, b squared is equal to 204 divided by 56, which means b is equal to square root of 204 divided by 56. And if I use my calculator, square root of 204 divided by 56, I will be given a 1.908 ... for the value. So my equation is n equal to 56 times parenthesis 1.908 ... to the t power. This is my particular, let me move over here so you can see particular equation. Does that make sense? Okay, so if that's the case, then let's go on to, this is part A. Go on to part B. Part B says predict based on the calculation the number of bacteria at t equal to 7. So that means t is put 7 into t. Then you end up with n equal to 56 1.908 dot 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 to the 7th power. Let's see what you have. Let's see, we to the 7th power times 56. I end up with 5166 millions bacteria, or 5.166 billion bacteria. Now this is approximate value, so I need to put a little wiggle line there, simply because I use numerical value instead of the exact form, which is square root of 204 over 56. So part C says, which day would there be 100 million bacteria? So that means part C is saying n is equal to 100 million, so 100. So I will have to put 100 for n, 56, 1.908 dot 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 to the t power, and I'm actually solving for t. So in this case, then I can divide both sides by 56. I end up with 100 divided by 56 is equal to 1.908 dot 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 to the t power. Now, so this is very interesting because right now our variable is in an exponent. Right now, our variable is an exponent. I need to solve for this exponent. And this is where what we've been learning of the interesting property of logarithm will start coming to help. So in this case, I know that if I have something in the exponent, I want to bring it over, I need to have a logarithm in front of it. So I can log on both sides. So why don't I do log base 10 of 100 over 56. I can log on both sides of the equation, 1.908 dot 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 to the t power. Now notice, if you have a t right here and there's a log right here, you can bring the t to the front. Okay, so then I'll rewrite this as log 100 over 56 equal to t times log of 1.908 dot dot dot. Well, then I'm just solving for t, right? So t simply be both sides divided by log of 1.908. So I have log of 100 over 56 divided by log of 1.908 dot dot dot. Now this then just it's just a matter of picking up your calculator and solving it, right? Let's see what the answer is when I type into the calculator. Just give me a moment. I got log 100 divided by 56 and divided by log 1.908, and I will end up with 0.897, and the unit of measure is days. So it's less than 1 day, but about 0.9 days. 0.9 days is when I will get 100 million bacteria. Now here the last problem says, part D says, sketch the graph. Well, if you want to sketch a graph, it's pretty simple, right? We sketch the graph. We know that this is time in terms of day, and the y-axis will be number of bacteria in terms of millions. And I know that at t equal to 0, we have 56. 2 days later, we have 204. Right? And so this is an exponential function right there. There you go. So that is the solution for problem number Alright, I will see you in the next video, and we'll continue on this packet in the next video.